The energy bill of a pumping facility includes the quantity of active and reactive energy consumed, fixed pricing, and any possible penalties applied if the subscriber exceeds the subscribed power level. In order to reduce the quantity of energy consumed and, consequently, the associated bill, it is possible to implement remedial technical solutions. In this module, we are going to present the main actions that can be implemented in order to optimize electro-pump unit and network energy consumption. Lastly, we will see how to optimize the cost of the energy consumed. Firstly, optimized, regular, and preventive pump maintenance is obligatory for all operators. This permits pumps to be maintained at maximum efficiency. In effect, in addition to specific energy monitoring, it is necessary to carry out checks and regular maintenance with respect to alignment, seals, bearings, and the motor. All of these actions permit the degradation of pump energy and hydraulic performances to be limited. It is of course necessary to choose pumps in such a way as to prioritize their operation within the maximum operating range indicated by the manufacturer, either during the technical design of a new pumping site or during the study to renew an existing facility. It is essential to remember that the higher the pump's nominal flow, the better its efficiency. It is nevertheless important to always check that the head losses remain limited. If the existing pumps have been oversized and are consequently operating outside of the maximum efficiency range, it is possible to replace them with pumps with different characteristics or to trim impellers. In order to guarantee the best efficiency of pump motors, it is necessary to select high energy efficiency motors. If the motors have been significantly oversized, they should be replaced, according to the principle that the maximum efficiency of a motor is situated between 3/4 and 4/4 of nominal head, whilst retaining a power reserve adapted to the site's operating mode. Secondly, various actions can be carried out at the level of networks and pumping sites' operating modes. A linear and singular head loss optimization and reduction program on networks can permit pumping energy consumption to be reduced, namely thanks to discharge pipe renewals if they're undersized or if pipe walls are extremely rough, or if the pipe section is reduced owing to clogging or corrosion. The putting in place of devices to reduce singular head losses on the network, such as valves, filters, production meters, and block valves. A regular maintenance of suction cups, which ensures discharge pipe pressurization without air pockets generating singular head losses along the pipeline. Actions on pump operating modes can also permit energy consumption to be optimized, namely through the parallel use of pumps, which must be planned according to the flow to be pumped during the day. Regulation, thanks to variable frequency drives with fixed or variable set points, depending on operating constraints. The optimization of TDH, thanks to drawdown at the level of suction on an upper section of the storage tank and filling by the base of the tank at discharge. This optimization can impact water quality. Lastly, various actions can enable energy supply costs to be optimized. A regulation mode, which permits pumping to namely operate during reduced tariff periods, allows for active energy costs to be reduced. Putting in place compensation systems, such as condensers, along with their regular maintenance, permits reactive energy costs to be reduced. Lastly, verifying subscriptions and electricity supplier readings for every pumping site permits the identification of overly high subscribed powers, but also pricing errors, which may generate extra costs. The main points to be remembered. In order to optimize pumping facility energy consumption, various actions can be carried out with respect to preventive and remedial maintenance, renewal, resizing, regulation, and control at both a hydraulic and an electrical level.